Good afternoon, folks. So what we're going to do today is the 2012 Ordinary Level Road Geometry question. This comes up in the section C of the exam papers on the Leaving Cert. So look, we'll just read through the question and we'll take it from there. So it says 2012 Ordinary Level. The accompanying map shows ground contours at 5 metre vertical intervals. So what that means is that the distance between our topography and our contour heights, 50 to 45, the gap between them is 5. On the drawing supplied, draw a vertical section profile along the line AB. So we have a line AB here that is cutting through the mountain, okay, as we see it in our plan view, and we want to see where it's cutting through with these various contour heights. So we're going to have to draw a profile up into space here. Part B, it is proposed to use the value of at B as a reservoir for the generation of hydroelectricity. Draw a line on the profile to indicate the maximum depth of water this value will hold. And then part C, CD is the centre line of a proposed roadway which is level at an altitude of 75 metres, using side slopes of 1 in 1 for the embankments, or otherwise known as fills. Complete the earthworks on the northern side that are necessary to accommodate the roadway. Okay, so we'll start off with part A, and we have to do a vertical section profile along the line AB. So first of all, I have to identify my contours. So just looking here, I can see all these 50, 45, 40, 35, 35, 40, 45. I want to know what this one is here. So it's 45 again, then we're at 40, 35, just seeing here is 30. So 30 seems to be the lowest, and 60 here at B seems to be the highest. So I can see 30 is here, and 60 seems to be the highest. Right, so with that information, okay, first of all we're going to work out our scale. Our scale is 1:2000. What that means is, put it in here, sorry, 1 millimeter on my sheet, OS, okay, equates to 1000 millimeters in reality, IR. And we have to work up to 5 meters, which is 5000 millimeters. So what do I multiply this by? I multiply it by 5. So therefore, 5000 millimeters on my sheet, if I multiply this by 5, I'd also multiply this by 5, equates to 5 millimeters. Sorry, 5000 millimeters, okay, in reality equates to 5 millimeters on my sheet. Okay, that's the scale we're going to work with there. So as I said, from the side here, I always like to start one lower, okay, when I'm doing a profile. So this line right here, I'm going to treat it at a height of 25. And then I'm going to measure up in 5 millimeter increments. So that'll be 30, 35, so I'm stepping up in 5s, 40, 45, 50, 55, and finally 60. So at B here, check the line up, that's the distance I have to go. Okay, so there we have it. Now I'll write in my heights. So 30, 35, 40, 45, 50, 55, and 60. Now it's just a case of identifying them. So basically what I'm trying to identify is where these contour lines are passing through the vertical section profile AB. So right at A, that one is at 50, so I project it up as far as the 50. The next one right here is at the 45. Here we have 40, this one we have 35, once again we have 35, then we have 40 again, so it's going back up, this one's at 45, next one now, I have to come down here, so that one was at 45, then I have actually another one at 45, and then I'm going back down to 40, so I'm just going to look here, 40, 35, 30, 30, okay, just make sure, so 40, yeah, then I have 35, yeah, 30, and 30, okay, just so I know that. So this one's at 40, this one's at 35, this one's at 30, and this one's at 30. Now I think after that 30 it goes up again, so 35, 40, so watch, 35 here, then 40 up to here, 45, 50, 55 and all the way up to 60. So it's just going up every one. So if the last one was at 30, next one's going to be at 35, 40, 45, 50, 55, and then finally this one was up to 60, so I'll just project that across a little bit further. Okay, I like to identify my points, so just make a little mark on them. Just helps me to see the profile a little bit clearer. Okay, and then I will sketch in my profile. So there's our profile done, guys, along the line AB. So if I was just to identify those points AB there. Alright, so there we have the profile done along the line AB, and that's part A done, so I'll just tick that off. Now part B, it says it is proposed to use the valley at V. Okay, so valley at V, so that's important here. So we've actually got two valleys here. You can see we've kind of got a valley here and we've got a valley here, but we're using the one at V, so it's this one. Okay, as the reservoir for the generation of hydroelectricity. Draw a line on the profile to indicate the maximum depth of water this valley will hold. Okay, so that's quite easy. So what we're doing is basically where the highest point is right here. Okay, and this is, I suppose, a little bit of a debate. Okay, so there might be a little bit of discrepancy on this. So you can see as the land was going down here and then it was going up here. Now because this point here was at 35 and 35, it doesn't really go flat across there because the direction of the land was going down. It's going to continue down for a second below the height of 35, and you can see here it's going to start going upwards. Okay, so as before it goes back up, it's probably going to dip down a little bit lower before it goes back up. Likewise, as it's going up before it goes back down over here, it's going to go up a little bit and then down. So you're kind of using the points afterwards to guide you there, and basically on how far it's going to dip down or dip above. So I dipped it down about this part. Now, just on that, we're going to use the height of this part here to determine how much water it could hold. So I'll put in a line across there, and that's kind of the water it could hold at its maximum there. Okay, going across, I've kind of created a tangent off that curve here at the top. And what I'm going to do is I'm going to identify the depth of it. Okay, and remember, 1 millimeter on our sheet equates to 1,000 millimeters in reality. So what I'm going to do now is I'm going to measure that distance then. So, best I can. And for me it's coming out to be 13 meters of water depth. Okay, so 13 meters in depth. So that's part B done. Okay. So draw a line on the profile to indicate the maximum depth of water this valley will hold. We've drawn that line. Okay, there's all the water, and I said it was 13 meters deep. So part C, CD is the centre line of the proposed roadway, which is level at an altitude of 75. So the road here is level at 75 meters height. That means the side of the road there is 75 meters in height. Okay, same over here. Now, what we have to do is, it says using side slopes of 1 and 1 for embankments. So what that basically means is, if I imagine this was a road here, and I took a slice through the road, look, there's a kind of a car on top there, okay? The road is at 75 here, and what we're going to use is, using side slopes of 1 and 1 for our fill, so our fill ratio, okay, it's gone off the sheet there now guys, sorry. Our fill ratio, alright, is 1 in 1. 1 is to 1. Okay, our fill ratio is 1 in 1. What that means is, for every 1 meter I step out from the road, or down, okay, I'm going to step out 1 meter from the road. Okay, so that means, look, if I put in a little triangle there, if I go 1 meter down, I'm also going to step out 1 meter. Okay, likewise, same thing again. So put in another meter down. There's my other triangle, you can see, so it's 1 down and 1 out. Now you can see I've gone 2 down and 2 out. Okay, but we have to use the scale that they've given to us. So if scale is 1:1, but that magic number we worked out earlier was 5. So that means we're going to multiply this by 5. So basically for every 5 meters I go down, I'm also going to step out 5 meters as well. Okay, so that's what we're going to use to help us. So if the side of the road is at 75, I'm going to measure up in 5mm increments. And just looking here, see how far we have to go down. 30 seems to be the lowest. Okay, is there any 75 part on the road? No, doesn't seem to be. So 30 is our lowest, so we have to work all the way down to 30. So step out 5, make a little mark there, that's going to be at 70, 65, 60. So we're working away from the road. 70, 65, 60, 55, 50, 45, 40, 35, 30. So there's all my marks. So I'll put in my 70 contour. There's 65, 60, 55, 50, 45, 40, 35, and finally 30. Okay, so there's all my contours. I would usually as well identify them. So look, I'll put in 70, 65, 60, 55, 40, 35, 30. And I just realised I actually went too many. 70, 65, 60, 55, 40, 30. Okay, so I put in an extra 2 by accident, guys, sorry about that. So there's 70, 65, 60, 55, 40, 35, 30. Okay, that's as far as I need to go. So I'll just scribble out that one there. Now, on your sheet, guys, you wouldn't always have to do these lines the whole way across. I'm just doing it here, okay, just for demonstration purposes. But as you're doing it, okay, if you just kind of had the height here marked here, and you could say, okay, 70, and you could come along here and just literally make a little mark on the 70 contour like that. Okay, probably keeps it a little bit neater than lines going all the way across your page. Okay, but if you want to do it this way, there's nothing wrong with it. Just make sure and keep your, I suppose, your neatness and tidiness. Okay, so starting off, I'm going to work, I'm just thinking I'll work left to right. So looking, the first one here we have is looking up at my contours here. So I've got the 41, 35, it's not going to hit it. Then I've got another 35. Yep, that hits right there. So you can see it here, 35. The next one I have is 40. It's probably getting closer to the road. So there's my 40 contour. The next one I have is 45. It's actually just looking here. My God, I made a mistake again, guys, sorry. Just realised, 55, there's 50, 45, my God, 40. So I was right, 35, 30. Did the same thing over here. This is 50, 45, 40. So I did need this one, as I said. There's our 35 and 30. Okay, you can see what can happen when you're rushing. Okay, so now I have to fix that. So the first one was at 30. So just looking here, there's 40, 35, just about hits here. Okay, so I was wondering what was going on in here. The next one's at 35 again. Next one's at 40. Next one's at 45. That's looking a little bit better. And then the next one, just looking over here, is also at 45. Then we have back up to 40. Then down to 35. I should say up to 35 in this case. Then up to 30. Then we're at 30 again. Then we have 35. Then I have 40. 45, so I'm getting closer to the road. 50. 55. 60. Most likely 65, yeah. 70. 70 again. Going back up. 65. 60. 55. Okay, so that looks a lot better. So I'll fill that in now, so I'll speed up the video. So there we have it, folks. That is part C done. Okay, so I'll just tick that off as well, where we have completed the earthworks necessary on the northern side of the road. Okay, sorry about the small little error there when I was just doing my measurements. Okay, I skipped a couple of them there. I had the right ones in, or the right amount in, and I thought I didn't. Okay, I went from literally 55 down to 40. But you can see there obviously how a small error can actually just throw you out massively. Okay, where I was identifying points and I was like, what's going on here? This doesn't look right. Okay. Just on this bit here, these are tadpoles. So what tadpoles identify is whether it is a fill or a cut. So if you were to imagine the road is higher than the land around it, so we're filling in that land. So if you were to start a ball over here, it would roll down away from the road. So the ball is here and it rolls away from the road as it goes down to meet the land, okay, below it. Okay, that's the idea behind it. So that question there, guys, is the 2012 Ordinary Level 1 done. Hope you found that helpful.